In this video, we will provide a detailed introduction to some of the applications under the Receive main menu. ADSB. The core function of ADSB application is to receive and decode the aircraft's broadcast signals, extract flight data, and display the data in real time on the map. First, we install the antenna for the device. Then turn on the device and click Receive and enter the ADSB application. Here we have LNA, low noise amplifier, VGA variable gain amplifier, amp amplifier, and a horizontal bar indicating the signal strength, and this is the volume. These settings will affect whether you can receive the signal and what kind of signal you will receive. You can try different values to explore different effects. Here are the call sign or ICAO number, the flight altitude in hundreds of feet, the aircraft speed. The amp is the signal strength. HIT is the number of data packets received. Age refers to the time since the last data packet was received, measured in seconds. All of these pieces of information will be listed here. When a signal is received, a beep sound will be emitted, like this. Here, we have received information about 3 aircraft. For example, the call sign of this aircraft is CSZ9368. The flight altitude is 2,400 feet. The flight speed is 435 knots. The signal strength is 2. The number of received data packets is 41, and the last data was received 1 second ago. When we click on this flight, the interface that appears will display ICAO number, call sign, airline, country, altitude, latitude, longitude, heading, and speed. If you want to obtain more detailed information, click AC Details, and you can see ICAO number, registration, manufacturer, model, type, number of engines, owner and operator. If you want to see the actual position of the aircraft on the map, click back, then click See on Map, and we can see the actual position and coordinates of the aircraft on the map. We can zoom in and out of the map, and you can clearly see other aircraft within the antenna range. But here, we don't seem to see any other aircraft. AISboats. In AISboats, here you have channels 88B or 87B, amplifiers LNA and VGA, horizontal bars indicating signal strength and volume. When a signal is received, the volume will make beeping sounds. Next is MMSI, which stands for Maritime Mobile Service Identifier, and it also includes the name or call sign. Finally, connect the antenna to the HEF-IS 88B channel using 162.025 MHz, while 87B uses 161.975 MHz. You can use any antenna that supports these frequencies for operation. After connecting the antenna, vessel information will be displayed on the screen. Due to the fact that the operation equipment was located far away from the water area, there was no antenna to capture any ICE signals. In fact, the received data packets were similar to those of the ADSB application, and we could also see the actual position and coordinates of the ships on the map. APRS. In this application, you can select your location, such as the Philippines, Europe, Thailand, and so on. Here, we still have frequency, AMP, LNA, VGA, signal bar, and volume. When using the APRS application, we must emit a signal source to ensure that the APRS RX can receive the signal. So here, I will use the APRS TX. In the other HackRF H4M to emit the signal. When we open the APRS TX application, The most common SSID is 0. So we will set both the source and destination SSIDs to 0. Then we will first input the names of source and dest. We can enter the transmission content in the info field below. Set the frequency to the APRS frequency in your area, such as 144.640 MHz. We also need to set the frequency of the other HackRF H4M to the same 144.640 MHz. And then click Start to send. Of course, we can also capture the APRS signal on another HackRF H4M. Audio. The audio application enables you to view and listen to any radio signals within the frequency range supported by HackRF. In this application, there will be an SDR waterfall graph that can visualize the received signals and offer several different modulation types for selection. By scrolling, we can select the mode we need among AM, NFM, and WFM, etc. Next is the current tuned frequency. Click on the tuning frequency and you can input the local broadcast frequency. When selecting the frequency, the step below can adjust the step size. There are also LNA, VGA, volume, and a horizontal bar for displaying signal strength. After setting the LNA and VGA, the amp can be set below. At this point, if we input the local broadcast frequency of 103.9 MHz, we can hear the audio. BLERX. Click to enter BLERX, which will only scan BLE broadcast data packets and display the packets on the screen. You can select the broadcast channel to listen to. The auto mode will gradually switch channels at a 25 millisecond interval. Here are also AMP, LNA, VGA, and signal bars. The sort button can sort the MAC number, hit count dB value, device name, etc. in ascending order. The filter button allows users to filter based on the hexadecimal data of each packet. The name button allows users to turn on or off the display of the name, provided that the device has a name association. The log button enables the BLA application to write all filtered packet data to the SD card. The USB log allows the BO application to write all filtered packet data through the USB serial port. Once the user is found, a separate MAC address entry can be selected to obtain more detailed information about the recent operation. The Export CSV function allows users to export the current packet entry list as a CSV format file. After resaving the file will update the existing entries with new data and add the new entries to the existing file. The TX button allows users to switch to the BLE sending application. The Clear button allows users to clear the input content when the screen content is full. ERT Meter. The ERT meter operates on the ISM frequency band, ranging from 902 MHz to 928 MHz, and is used for automatic meter reading of water, gas, and electricity. It supports protocols such as IDM, SCM, and SCM+. Here, ID represents the instrument serial number, TI represents the instrument type, Consumt indicates the meter reading value, and TAMP represents the tamper-proof label. CT represents the count of the number of readings that have the same instrument number. Only when the surrounding electricity meters use the protocols supported by ERT can signals be received. Therefore, I am unable to receive signals here for the time being.